Hello and welcome to the lecture series of GTU Engineering Physics, module number 3, ultrasonic and non-destructive testing. I welcome you all students for the viewing this video lecture. This entire module is divided into 7 parts, out of which first part, introduction to ultrasonics and few important properties of ultrasonics will be discussed in this lecture. So, let me introduce the ultrasonic waves or sound waves initially. So, give title to this topic as introduction. Introduction. So, let me start it with the sound waves. So, ultrasonic waves are, we can write like this, ultrasonic waves are sound waves. Ultrasonic waves are sound waves of high frequency of high frequency. So whenever someone asks you what is ultrasonic wave, then you may say that ultrasonic waves are nothing but a sound wave, but frequency of ultrasonic wave is higher than the audible frequency. આપણે જે સાંભળીએ છીએ એ જે ધ્વનિ તરંગો છે એના કરતા વધુ આવૃત્તિ વાળા જે તરંગો હોય એને sound waves કહેવાય. So now let us understand what is sound waves. So basically sound waves are sound waves are longitudinal longitudinal waves. હવે તમને એમ થાય longitudinal એટલે હું અહીંયા ગુજરાતીમાં લખું છું સંગત તરંગો. So sound waves are longitudinal waves in which oscillations of particle is in the direction of in the direction of propagation. So sound waves are longitudinal waves. So what do you mean by longitudinal waves? Then we can say that the longitudinal waves are the waves in which the oscillations of particle of medium is in the direction of propagation. For example, suppose this is the direction of propagation. This is suppose direction of propagation. Then the particles are oscillating. Suppose this is the particle, this is second particle, third particle, fourth particle, and so on. So this particle are oscillating in this direction, back and forth, as you all are aware about the oscillations. So the particles are oscillating in this direction and the direction of propagation is this. So this is the direction of oscillation. So the oscillations of particle is in the direction, or we can say that it is parallel to the direction of propagation. So as we all are aware about two types of wave, longitudinal waves and transverse waves, સંગત તરંગો અને લંબગત તરંગો. તો લંબગતમાં તમે ભણી ગયા, પ્રકાશના તરંગોમાં તમે એવું ભણી ગયા છો કે that type of waves in which the direction of propagation and oscillations are perpendicular to the direction of propagation. એટલે તરંગ પ્રસરણની દિશાને લંબ દોલનો થતા હોય. But that is not the case for sound waves. Sound waves are longitudinal waves and longitudinal waves are the waves in which oscillations of particle is in the direction of propagation. The second point about the sound waves or longitudinal waves is this: they are propagating in the medium through through condensation condensation, or it is also known as compression and rarefaction and rarefaction. So, sound waves or any longitudinal waves are propagating in the medium through condensation and rarefaction. The condensation means in Gujarati it is Sanganan, rarefaction is known as વિઘનન. So સંઘનન અને વિઘનન વડે આવા તરંગો છે એનું માધ્યમમાં પ્રસરણ થતું હોય. So they are propagating in the medium through condensation and rarefaction. Let us understand that thing also. Suppose this is a part of medium, and as we know that all the particles are randomly moving inside the in this region. એટલે ધારો કે આ હવાના બધા કણો છે and they are actual distance between any two particle is constant during the motion of particle. વાયુમાં બે અણુઓ વચ્ચેનું અંતર લગભગ બધા માટે અચળ હોય છે. Now when the wave is propagating in this type of medium, suppose sound wave is propagating in this, then what happen during the propagation, the region, so see these are the oscillations of particle. So at some instant the particles come close to each other in one region, and these particles are coming from the nearby region. So here the particle density decreases. Again there is a region in which the atoms or particles come close to each other. એટલે એક જગ્યા એવી હોય કે જ્યાં પાર્ટિકલની સંખ્યા ઘનતા છે એ વધી જશે. દોલનો છે એના પરિણામ સ્વરૂપ શું થશે કે એક રિજિયનમાં પાર્ટિકલ ડેન્સિટી છે એ ઇન્ક્રીઝ થશે અને એ પાર્ટિકલ આવ્યા ક્યાંથી હોય એની બાજુના વિસ્તારમાંથી. So this type of regions are formed in when the wave is propagating in the medium. Whenever the particle, suppose this particle is oscillating in this direction, so these particles come close to each other and here particle density increases. So wherever particle density increases, we say that condensation or compression is formed at that point. ત્યાં સંઘનન રચાયું એમ કહેવાય. And where the particle density decreases, at that point we can say that rarefaction is formed. Rarefaction is formed. So we get the regions like this. This is condensation, let us say C. This is rarefaction R, C, R, C, R, C, and so on. And the distance between two consecutive condensation is equal to lambda, which is known as the wavelength of wave. So by condensation and rarefaction, the sound waves are propagating in the medium. તો એક તમને ખબર હોવી જોઈએ કે ultrasonic waves are sound waves. Now but what is sound wave એ તો ખબર હોવી જોઈએ. So for the introduction to sound wave, we say that the sound waves are longitudinal waves. So what do you mean by longitudinal waves? So in the answer of that, we say that the longitudinal waves are the waves in which oscillations of particle is in the direction of propagation. Now how the sound waves are propagating in the medium? To answer that question, we remember two words. One is condensation or compression, and second one is rarefaction. So we can say that the sound waves are propagating in the medium via or through condensation and rarefaction. Now again there is a question, what do you mean by condensation and rarefaction? So whenever the sound waves are propagating due to the parallel oscillations of molecule or particle, in some region particle come close to each other and from the nearby region. So here particle density increases, here particle density decreases. The region where particle density increases is known as the condensed region, or it is known as the condensation. And where the particle density increases, rarely particles are available in this region, therefore they are known as the rarefaction. Again we get condensation, rarefaction, condensation, rarefaction, condensation, rarefaction. After to formation of condensation through in this region is up to t by 2 time. After t by 2 time, half of the time period, the rarefaction is formed in place of, કેમ કે આ પાર્ટિકલ આમ ઓસિલેટ થયો એ પછી જ્યારે આમ ઓસિલેશન કરશે એટલે rarefaction છે ત્યાં બધા ભેગા થશે. So at the place of rarefaction condensation is formed, and at the place of condensation rarefaction is formed. So condensation, rarefaction, condensation, rarefaction, condensation, rarefaction, and so on. Whenever up to the time where the sound wave propagating, till that we get the condensation and rarefaction. Once the wave passes, again they are distributed randomly in that region. So this is how these sound waves are propagating in the medium. Okay, so this is about the basic properties of sound wave. And let me tell you the last property. Sound waves are mechanical waves, are mechanical waves. So they require medium to propagate, medium to propagate. So as we know that sound waves cannot be propagating through vacuum, it requires medium, so they are mechanical waves. And the first most important topic is the classification of sound waves, classification classification of sound wave based on frequency, based on frequency. So this is actually our first topic of this unit. See, the અત્યાર સુધી મેં જે પહેલા કરાયું એ બધું તો એવું છે કે જેમાં તમારે જૂનું જે 11 12th માં ભણી ગયા હો એનું એજ આવ્યું હોય. Now we divide the sound based on the frequency. So uh, write like this: sound wave, sound wave, sound wave. Uh, there are three types of sound waves. There are three types of sound waves. The first one is known as the infrasonic or infrasound. The second one is known as the audible sound, and the third one, which is our topic of interest, is ultrasonic or ultrasound. Now let us understand each in detail. As we know that this distribution is based on the frequency, infrasonic waves are the sound waves having frequency f less than 20 hertz. So these waves are low frequency sound waves. Sound waves having frequency less than 20 hertz are known as infrasonic waves. The audible sound is the sound for which human ear is sensitive. એવો ધ્વનિ કે જેના માટે આપણો કાન છે એ સંવેદનશીલ છે. આપણે જે મનુષ્ય છે એ સાંભળી શકે છે એ આવૃત્તિનો જે ગાળો છે એને આપણે ઓડિબલ કહીએ છીએ. સો ઓડિબલ ફ્રીક્વન્સી રેન્જ ઇઝ બિટવીન 20 hertz to 20,000 hertz, or we can say like this, 20 hertz to 20 kilohertz. So these are same. These are same. This is in hertz, this is in kilohertz. બે એકનું એક જ છે, અલગ અલગ રીતે લખ્યું છે. So the sound waves which are audible to human ear are known as the audible sound. Any sound having frequency in between 20 hertz to 20 kilohertz are audible. આનાથી 20 હર્ટ્ઝ થી નીચે આવૃત્તિના જે ધ્વનિ તરંગો છે આપણે નહીં સાંભળી શકીએ. 20 કિલોહર્ટ્ઝ થી વધુ આવૃત્તિના જે તરંગો છે એ પણ આપણે નહીં સાંભળી શકીએ. So this is audible sound. And ultrasonic waves are the waves having frequency f greater than 20 kilohertz. So the sound waves having frequency more than 20 kilohertz are known as ultrasonic or ultrasound. Now let us understand this. આ તમારે ઘણીવાર આવી ગયું, હવે તમને ખબર હોય infra ને ultra નો meaning શું છે. Now see, this is very famous word. One is infra and second is ultra. So sonic is the word which is used for the sound. તમે અહીંયા જો sonic ની બદલે sound લખો તોય ચાલે, અહીંયા sonic ની બદલે sound લખો તો પણ ચાલે. So infra is the word which is used for less than માટે infra નો ઉપયોગ થાય, અને ultra જે છે એ આપણે વાપરીએ છીએ more than માટે. બરાબર બરાબર સમજો. ઇન્ફ્રારેડ અને અલ્ટ્રા વાયોલેટ એવું તમે વિઝિબલ સ્પેક્ટ્રમ જ્યારે ભણતા ત્યારે આવતું. તો જો પ્રકાશના તરંગ હોય તો ત્યાં એવા વર્ડ હોય. તો જુઓ, આપણા માટે અગત્યનું આ છે, હ્યુમન is the audible range for human is 20 to 20 kilohertz. So any sound having frequency less than the audible word or audible sound, we use the word infra before the sonic or sound word. So sound which is less than the audible sound is known as infrasound, and ultra is used for more than meaning of ultra is more than something. So maximum limit to audible sound is 20 kilohertz. Maximum frequency which is audible to human ear is 20 kilohertz. So any sound having value more than that, we use the word ultra. So ultra means more than audible sound, infra means less than the audible sound. So there are three category of sound waves which are based on the frequency. One is infrasonic having frequency more less than 20 hertz, audible having frequency in between 20 to 20 kilohertz, and ultrasonic or ultrasound having frequency more than 20 kilohertz. And this topic is important. This is first important topic. They may ask 1 mark question or MCQ type question that what is the frequency range for infrasonic or ultrasonic or audible sound, and many more. So this is the first important part. Now see, in this unit, module number 3, we will discuss only about the ultrasound or ultrasonic waves. In this unit, in this module, we will discuss only ultrasonics. So that is our unit or unit name or introduction to the ultrasonic. What is ultrasonic? તો તમને પહેલા એ ખબર હોવી જોઈએ કે સાઉન્ડ વેવ છે. તો સાઉન્ડ વેવ બધાની પ્રોપર્ટી સરખી જ હોય, પણ એમાંથી અલ્ટ્રાસોનિક કેવું, તો કે જે હાઈ ફ્રીક્વન્સી વેવ છે એને આપણે અલ્ટ્રાસોનિક કહીએ છીએ. સો In this unit, we will discuss only about the ultrasonics. So first topic is for the ultrasound is the properties of ultra properties of ultrasound or properties of ultrasonic. Sonic kyo કે sound kyo બે સરખું જ છે. So let us discuss one by one the properties. First property, write down with me, frequency of ultrasonic wave is greater than 20 kilohertz. So we see earlier that any wave having frequency more than 20 kilohertz are referred as ultrasonic waves. So એ તો આપણને ખબર જ છે, but that is our first property. Now second, this is important, as frequency of ultrasonic waves is high. Out of all these waves, the maximum frequency contains ultrasonic waves. It has short wavelength. It has short wavelength. હવે એ ખબર કેમ પડે? We know that this V is equal to F lambda. So lambda is equal to V by F. As the frequency for ultrasonic wave is the maximum out of all these three waves, so wavelength is very less. So they are short wavelength sound waves. એવું પણ કહી શકાય, high frequency wave or short wavelength wave. So it has short wavelength, and as it has short wavelength, the penetrating power is very high. So it has high penetrating power. Penetrating power. So penetrating power એટલે આપણે કહીએ વિભેદન શક્તિ. વિભેદન શક્તિ કોઈ પદાર્થમાં અંદર સુધી ઘૂસી જવાની ક્ષમતા, જેમ કે એક્સરે છે એનો પેનિટ્રેટિંગ પાવર વધારે છે એટલે આપણને એ જે ઇમેજ જે છે એ બાકીના બધાની આપે છે. એટલે હાડકાનો એક્સરે આપણે પાડીએ છીએ કેમ કે ચામડી જે છે સ્નાયુ એના અંદર સુધી ઘૂસી શકે છે. So it has why? Because X-rays are short wavelength waves. So like that, frequency is more. So as frequency is more, we say that lambda is short, and short wavelength can penetrate more through the material. So it has high penetrating power. Third is, as they have high frequency, the energy is very high. So they have high energy content. So you can write like this also, they have very high energy, or ultrasonic waves are high energy waves, એવું પણ તમે લખી શકો. So as frequency is more, energy is also high. Just like ordinary sound waves, ultrasonic waves get reflected, refracted, absorbed, interfere, diffract, etc. તો જે ઘટનાઓ સાદા તરંગો સાથે થાય છે, જેમ કે રિફ્લેક્શન મીન્સ પરાવર્તન, રિફ્રેક્શન મીન્સ વક્રીભવન, એબ્ઝોર્પ્શન તમને ખબર છે શોષણ, ઇન્ટરફિયરન્સ એટલે વ્યતિકરણ, ડિફ્રેક્શન એટલે વિવર્તન. સો જસ્ટ લાઈક all other sound waves or all other waves, ultrasonic waves are also reflected, refracted, absorbed, interfered, and diffract. So we can see such type of phenomena for ultrasonic wave also. But we cannot polarize any longitudinal waves. Longitudinal waves હોય એનું polarization ક્યારેય નહીં થાય. એટલે એક એ વસ્તુ આપણે યાદ રાખવી પડશે. They cannot be polarized. So ultrasonic waves, we cannot get the polarization process. As it has high energy, we can say that ultrasonic waves ultrasonic waves can be can be transmitted transmitted over large distance with no loss of energy, without loss of energy, with no much loss of energy. Loss of energy તો થશે જ પણ ખૂબ જ ઓછો energy loss થશે. So ultrasonic waves can be transmitted over the large distance with negligible loss of energy, and therefore they are used for the communication between submarine. We will see one topic, namely sonar, which is used for the communication from one submarine to another submarine inside the sea. So ultrasonic waves can be travel more distance without much loss of energy, as it has high value of energy or high value of power. They produce intense intense heating effect intense heating effect when when passed through when passed through a substance when passed through a substance. So now it has high energy. So whenever it is passing through any object, they produces heating effect. So this is one of the property, and this is last and important. Ultrasonic waves ultrasonic waves form stationary wave stationary wave in a liquid waves in a liquid column, which acts as diffraction grating diffraction grating and this type of grating is known as acoustic acoustic diffraction grating acoustic diffraction grating. So this we will discuss in detail when we will study about the velocity measurement of ultrasound with the help of acoustic diffraction grating. So what is grating? What is acoustic diffraction? How liquid column is? How stationary waves are formed in liquid column? That we all discuss later on in our upcoming lectures. So right now you have to remember that the ultrasonic waves, when they are passing through a liquid column, they produces the stationary wave. આપણ તમને કહી દઉં stationary wave એટલે સ્થિત તરંગો. તમે જે 11મા ધોરણમાં ભણીને આવ્યા છો એ સ્થિત તરંગો. લિક્વિડ કોલમ એટલે પ્રવાહી સ્તંભ પ્રવાહી સ્તંભ એટલે એક નળીમાં પ્રવાહી ભરી અને ઊભી રાખી હોય તો એને લિક્વિડ કોલમ કહેવાય. ડિફ્રેક્શન એટલે વિવર્તન, ઈ તો તમે ભણી ગયા છો. સો ultrasonic waves can form stationary wave inside a liquid column, and this acts as a diffraction grating, which is known as the acoustic diffraction grating. So these are the properties of ultrasonic wave. There are more properties also, but the major properties are discussed here. 1 to 8 properties. In suppose GTU છે તો એમાં તમને 4 માર્કમાં પૂછાય કે 3 માર્કમાં પૂછાય તો તમારે એક પ્રોપર્ટીનો 1 માર્ક હોય છે જનરલી. સો they will ask for 3 or 4 mark maximum. So you need to remember any 5 or 6 properties out of this 8, and they are very easy to remember. So these are the introduction and properties of ultrasound. As we Our title of this first lecture is only about the introduction, and then after introduction of ultrasound, we have to discuss the properties of ultrasound. So these are few properties of ultrasound. Uh, then after, there are method to produce ultrasound, which are known as production techniques. So the second topic of our unit is the production of ultrasound. The production of ultrasound, and they are known as ultrasonic. They are known as ultrasonic generator. એમ એસી જનરેટર, ડીસી જનરેટર એવું તમે ભણી ગયા છો, એમ અલ્ટ્રાસોનિક જનરેટર એ જનરેટર નામ પરથી જ ખબર પડે, they are used to generate the ultrasonic waves. So the second word for generator is oscillator. Oscillator is the instrument which produces waves only. So ultrasonic oscillator or ultrasonic generator બે એક ના એક જ શબ્દો છે, but we use the word generator in it. So production of ultrasound can be done with the help of two method. First one is electrical generator. We can produce it with the electronic circuit. They are known as electrical generator. And the second part is known as the mechanical generator. Mechanical generator. Now they are rarely used. Mechanical generator are very few, and they are hard to construct. But nowadays electronics is very easy. Circuit parts are available easily in the market. So electrical generator are more famous than the mechanical generator, and we have to discuss only electrical generator in the production techniques. We uh, have to discuss two generator. One is based on the magnetic effect, which is known as magnetostriction magnetostriction generator or oscillator. So first generator which uses the magnetic phenomena, which is known as magnetostriction effect, the generator named from the same effect, which is known as the magnetostriction generator. And the second is based on the similar type of electrical phenomena like magnetic. They are known as piezoelectric generator. Piezoelectric generator or oscillator. So one generator uses a magnetic phenomena, which is known as magnetostriction effect, and the generator which is based on that effect is known as magnetostriction generator. And there is another phenomena which is known as inverse piezoelectric effect, and the generator which is based on the piezoelectric effect is known as piezoelectric generator. So this is the electrical version of the magnetostriction generator. So these are very important. These two generators are very, very important in alternate exam GTU, uh, there are two questions based on the ultrasound, and one generator is there for 5 or 7 marks. So ગમે તે તમે જીટીયુ ની પરીક્ષા લ્યો તો એમાં લગભગ 5 કે 7 માર્કમાં બેમાંથી એક જનરેટર હોય ને હોય જ. So out of all the topics which are in our syllabus or which are in our unit, these two generators are the most important topic of this unit rather than in the syllabus. આખા સિલેબસના જો સૌથી અગત્યના ટોપિક હોય, સૌથી ઇમ્પોર્ટન્ટ ટોપિક હોય, સૌથી વધુ જીટીયુમાં પૂછાતા હોય એવા ટોપિક હોય તો એ આ બે જનરેટર છે. So one is magnetostriction, another one is piezoelectric generator. Now in our next two consecutive lectures, we will discuss magnetostriction generator in first lecture and piezoelectric generator in the second lecture. So this is the only introduction about the production of ultrasonic waves. We will discuss the generators in our upcoming lectures. Now see, there is one book which is titled as, let me write the name of the book, uh, Physics, Physics for Group 1 branches. Physics for Group 1 branches by Keyur Khatsurya, that is me, Hem Bhatt, and Pratik Lakhani. There are three authors by Pratik publication. We will discuss all the topics from this book. Book which we refer for this entire unit is the Physics for Group 1 branches by Pratik publication. So these are the PDFs of those of this book. For better understanding, better to purchase this book. It is available freely. It is available in reputed bookstalls also. So this is our subject code 3110011, in which we're discussing module 3, ultrasonic and non-destructive testing, which is known as NDT. So it has two part. First part is ultrasonic and second part is non-destructive testing, NDT. These are the topics of our syllabus. See, ultrasonic waves, properties, production of ultrasonic waves, in which we have to discuss two generators, piezoelectric and magnetostriction. So today we discuss the ultrasonic waves and its properties. So these are the topics. Then after, detection of ultrasound and application of ultrasound. So there are two parts of this unit. This is part number 1, in which we have to see what is ultrasound and its application. અહીંથી અહીં સુધીનું ખાલી ultrasound નું જ છે. Then after, next part will start, which is the introduction to NDT. What is advantages of NDT over DT, and NDT through ultrasound. So this is our part number 2. This is part 2 of this unit. So entire unit is divided into two parts. Weightage of this part is 75 to 80%, and weightage of this part is 25 to 20%. So this part is very small as compared to this, but together this they have weightage of almost 25% in the GTU examination. So for GTU, this unit, entire unit module number 3, is very much important than the other units. So these are the topics. Uh, See, the first topic 3.1 is about the introduction to ultrasonic waves. So in that we were discuss about in today's lecture only, what are sound waves. So sound waves are longitudinal waves propagating in elastic medium through, see, change here, not crest and trough, through condensation and rarefaction. અહીંયા એક ચેન્જ કરજો, સુધારો. Not crest and trough, they are propagating through condensation and rarefaction. And as we discussed that the sound waves require medium for propagation as they are mechanical waves. And we classify the sound based on the frequency. We get three types of sound waves. One is infrasonic, having frequency less than 20 hertz, audible sound having frequency in between 20 to 20 kilohertz, and ultrasound or ultrasonic waves having frequency more than 20 kilohertz. So these sound waves having frequency greater than 20 kilohertz are known as the ultrasonic waves, and they are used in medical diagnosis. You heard the word sonography. So sonography uses the sonic waves, that is sound waves, and that they are ultrasonic waves. In physiotherapy, ultrasonic waves are also used. In marine application, as I told you that between the submarine to submarine we can use ultrasonic wave for the communication purpose and non-destructive testing, which we later see in this same unit also. And then after, this is our today's main topic, which is properties of ultrasonic waves. And we saw all these properties. Let us discuss once more, turn by turn. Frequency of ultrasonic wave is greater than 20 kilohertz. As we know, they are high frequency waves. And as frequency is high, it has short wavelength and therefore they have high penetrating power. As they have more frequency, energy of such waves are very high, and they experiences reflection, refraction, all the optical, all the phenomena which are related to wave, they can experience. Ultrasonic waves can be transmitted over a large distance with no appreciable loss of energy, as they have only already high energy. They produces intense heating effect when passed through a substance. And we form the acoustic grating, which is known as the diffraction grating, with the help of ultrasonic, as they form stationary wave inside a liquid and act as a diffraction grating. So these are the properties of ultrasonic waves. In our next lecture, we will discuss one of the generator, first one, which is magnetostriction generator. I hope this lecture will be useful in your study. Thank you very much. We will meet in the last lecture. Thank you so much.